on chapter 7, day 5. Zero exponents. We haven't worked with zero exponents or an exponent of zero yet. And what you're going to find out is that anything, almost anything, to the zero power equals 1. There's a good reason for that, and when we talk about negative exponents, you can do it. But if you want to try it on your calculator, hit any number that you want. Hit the power button, which is over here by the 7, kind of diagonal. If you raise any number to the zero power, you're going to get 1. There is one exception to that rule, and that is 0 to the zero power is undefined. So 5 to the zero power equals 1. Why does that work? Because what we know about division is that for the quotient rule, you have to subtract exponents. So let's say that we have x to the 7th power divided by x to the 7th power. We've known this about math our entire lives since we started dividing. Anything divided by itself is 1. Anything divided by itself is 1, no matter what those two things are, except 0. Anything divided by itself is 1. So it also fits the rule of if you have a quotient, same base, you subtract exponents. Well, if anything to the zero power equals 1, then it also has to fit the rule of anything divided by itself equals 1. Anything divided by itself equals 1, which is the same as the quotient rule, so anything to the zero power also has to equal 1. You can't solve the same problem two different ways and get two different answers. So, again, with the zero power, that's a shortcut of multiplication and division. Exponents are shortcuts of multiplication and division. 0 to the zero power is undefined. Why is that? Because if you took 0 to the 7th power instead of x to the 7th power, you can't say that that equals 1. Anything divided by itself is 1. You heard me say it before, except for 0. If anytime you ever try to divide by 0, it's undefined. So you're going to write the 0 rule in your notebook. Pause this if you need to. 0 rule, there's kind of two rules. Anything to the zero power equals 1, but 0 to the zero power is undefined. Pause it so you can get that written down. Circle it. That's now our 5th rule, I believe. We have product rule, quotient rule, power rule. Maybe this is only our 4th. 0 rule. If it's in parentheses, as it is, -7, all of -7 is raised to the zero power, which means it equals 1. If it's not in parentheses, then this is saying 7 to the zero power is 1, but we want the opposite of that. The opposite of 7 to the zero power, and you'll be able to tell that on your calculator also if you type it in properly. Left parenthesis, -7, right parenthesis, power of 0. You type that in, you get 1. But if you just type in -7 to the zero power, your calculator knows that it wants the opposite of 7 to the zero power, or the negative of 7 to the zero power. Okay, we'll do some more with negative exponents. So we're not only going to work with zero power today, because you'd be done with your notes already and your assignment would be way too easy. Negative exponents. This says if you have any kind of negative exponent, that this base actually belongs down here in the denominator. This x with its exponent moves down here to the denominator. Change the power to a positive, and because you can't have an empty fraction or an empty numerator up here, you put a 1 up there. So it's 1 over x to the 3rd. And I already know what you're thinking. Like, what? Well, how? We're going to go back to the quotient rule again. Let's go back to the quotient rule. You know that if you divide two numbers, when dividing, as long as they have the same base, you keep the base and subtract exponents. 7 minus 4 is 3. And the reason we knew that back in the past, we did this already, you don't have to write this all down, is there's 7 of those and 4 of those on the denominator, and they all cancel. You're left with x to the 3rd. Well, now let's reverse it the other way. What if you had x to the 4th over x to the 7th? We just said that that equaled 1. Well, actually, let's do the math first. It'll be x to the 4 minus 7, which is negative 3. Now it's x to the negative 3. We've already practiced this just to make sure we knew how to subtract properly and work with negative exponents, but I allowed you to stop right there. That's not mathematically correct. We only learned half of the issue. What we have to do from there is then say that negative 3 says that all of the x's that were left were in the denominator. They weren't in the numerator, and we put a 1 over the top. Let's check it out here. This said there were 4 x's on top. This says that there are 7 on the bottom. If you cancel these all out with all of these, you have 1 left on top, the number 1, because this is 1 times 1 times 1 times 1. What do you have left in the denominator? 1, 2, 3. So if I made you do it the long way every single time, you would never get this wrong. But the shortcut is subtract the exponents. 4 minus 7 is negative 3, and then move the base and its power to the denominator. And the power becomes positive. So what does x to the negative 4th equal? 1 over x to the positive 4. We're going to keep it simple compared to what you're going to do in Algebra 2. In Algebra 2, you're going to get really in-depth into negative exponents, but you're going to get a nice intro here. Write it down. X to the negative 5th becomes x to the positive 5th, but that's in the denominator. And because, again, you can't have an empty fraction, you put a 1 in the numerator. Or you could actually say, I know that there's a 1 here. There's always a 1 in front of a variable, even though you can't see it. So our 1 stays where it is, and our x to the 5th moves down. Same with x to the negative 8th. Go ahead and write yours down. You can pause it here if you want and check on anybody and see if you got the correct answer. 1 over x to the 8th. So let's do the negative exponent rule. Says move the base and the exponent to the denominator. Move the base and the exponent to the denominator. Make the exponent positive. Pause it, get that written down. Our 5th and final rule of exponents. All right, so what if there's not a 1 in front of the number? This time you can see it's a little bit different. We have a 2 as our coefficient in front of the y. It said move the base and the exponent to the denominator. Make the exponent positive. Well, this time instead of being a 1 left on top, there is a 2 left in the numerator. Leave the 2 alone. That doesn't move down. Only the base and the exponent move. Write this one down. How does that one look? X squared stays where it is. Nothing changes. Y to the 5th moves to the denominator. Anytime you have a negative exponent, it's going to move to the denominator. 4h to the 6th, g to the negative 3rd. 4h to the 6th, you leave that alone. Don't change anything. But g to the 3rd is going to move down there. That's not so bad, right? Try this one. This one has 2 negatives, but they each have their own base, so it doesn't follow the rule of 2 negatives multiplied and make a positive. They each have their own base. The 5 stays where it is, and a to the 5th, b to the 2nd moves to the denominator. The nice thing is these problems are pretty short. They don't take very long. They don't take a ton of thinking. They don't take a lot of step-by-step like solving multi-step equations. But you're going to have to think through some of them like this. Go ahead and write it down. X to the negative 5th over y squared. X to the negative 5th moves to the denominator. Don't move the y squared. It is already positive. It doesn't get to go anywhere else. It just sits down here next to your x to the 5th, and I put the x first because it's alphabetically in order. Again, no empty fraction, so a 1 goes up there. Move the x to the 5th. down by its friend y squared and put a 1 in the numerator. We've got a few more to go. 6, a to the negative fourth, b to the 0. Now we're combining two rules, the 0 rule and the power rule with negative exponents. So we've got a negative exponent here. We have anything to the 0 power equals 1. So you can turn that into a 1 right away. But remember, this is all multiplication. 6 times a to the negative 4 times 1. What is 6 times 1? It's just 6. So basically, you just got rid of the b to the 0. If there are no b's, why would you even write down that there are no b's? I don't know why they told us that, just to make sure you knew. And then the a to the negative fourth, because it has a negative exponent, you take its base down to the denominator and make the exponent positive. Notice I didn't move the 6. The 6 doesn't belong there. If you had to, and if it helped, you would write this separately as 6 times a to the negative fourth times 1. A to the negative fourth stands alone, moves to the denominator. 6 times 1 is 6. Ready? Now we're going to put it all together. First, you're going to do the product, quotient, power, and 0 rules. And then when you're done, take care of the negative exponents. Pause it if you need to write this down. Okay, we're back. Looks like we have the product rule. I'm going to show all my work. You're going to probably show all your work. We talked about the commutative property. Commutative property, you can rearrange any multiplication. 4 times 3 belongs together because these are both whole numbers. And you're multiplying. X to the negative 3 belongs with x squared. And you put those together. Do the math. 4 times 3 is 12. Do the math. The product rule says when multiplying, keep the base, add exponents. Negative 3 plus 2 is negative 1. First, do the product rule. Got it. Then, take care of negative exponents. Our 12 stays in the numerator. Our x to the negative 1 moves down to the denominator and becomes a positive. But you absolutely positively will not ever in your math career put a 1 exponent. Just like we never put a 1 coefficient, we will never put a 1 exponent. Not in your final answer. If it's in your work, it's fine. In your final answer, it's not. I know, you're looking at this one like, what? We're going to this right away? It's not bad. Just write it down. Pause it if you have to. Okay, you should have it all written down. We're going to start with the commutative property because we're product. 3 times negative 6 belongs together. K to the negative 2 times k to the 4th belongs together. And n to the 3rd, n to the negative 5th belongs together. What does that look like when you simplify? 3 times negative 6 is negative 18. Add exponents when multiplying. Negative 2 plus 4 is 2, so you have k squared. And with the ends, 3 plus negative 5 is negative 2. You're not done yet. It said first do the product rule. Now we have to rewrite this. Take care of the negative exponent. Negative 18k squared stays up here. N to the 2nd moves down there. Oh, right, I know. This is one of those that you're going to say, Mrs. Bester, you made a mistake on the video again. I know that you screwed it up. I'll just tell you that you can fix it. I didn't make a mistake. You're thinking, but that negative 18, it's negative, and we just learned that you have to move negatives to the denominator. Right. Negative exponents move to the denominator. This is a negative whole number. It's just negative 18. There's no negative exponent up here on it. So leave the negative 18 alone. Move the n squared down. All right, we have 1, 2, 3 left, so hang in there. Write this one down. Again, pause if you need it. I don't know if I have to keep saying that. Now we've got power rule. We just did 2 product rules. Now we've got power rule. Everything gets a power of 4. Starting with parentheses, -3 gets a power of 4. And I already showed you that on the calculator, the difference between typing in -3 to the 4th and parentheses -3 to the 4th. Keep the parentheses. X to the -5th gets a power of 4. And y to the 3rd gets a power of 4. Power. We are powering -3. It is not -3 times 4, which is -12. It is -3. There's always such a glare, sorry. -3 power 4 equals 8. 81. There we go. 81. -3 to the power of 4 equals 81. So we start there. 81. Now we do our x's. Power rule of exponents is that a power of a power gets multiplied. Keep the base, multiply the exponents. And with the y's, 3 times 4 is 12. And I know, I just said it's not 3 times 4 is 12 over here. But that's because that's a whole number. -3 power 4. These are both exponents. 3 times 4. The 81 and the y to the 12th is going to stay as is in the numerator. The x to the 20th is going to move down in the denominator where it belongs. Last 2, we've got to do the quotient rule. I know these freak you out because they look like fractions. Just think of it as division. We'll do the associative property. The associative property, we're going to associate. We're not going to really move anything around. 6 over 3 together. We're going to associate a to the -7th and a to the -2 together. Take care of each one separately. 6 divided by 3 equals 2. A, -7 minus, I should probably move that down. -7 minus -2 plus. You get 2a to the -5. And you finish with the 2 in the numerator and a to the 5th in the denominator. And finally, one more fraction, one more quotient rule. Write it down, be careful, look carefully for your negatives, pause it. All right, you're back, you have it all written down. I'm going to do multiple colors again here. We'll do 8 12ths and associate that together. X to the 3rd over x squared and associate those together. And y to the -4 over y to the -3. I forgot to do multiple colors, but I think you can see it. 8 divided by 12. No decimals. No decimals. If you can't take 8 12s and reduce it on your own, do 8 fraction 12. Your calculator does all the work for you if you wanted to. 2/3. Leave it as 2/3. Do the second one. X to the 3 minus 2. Do the third one. Y to the -4 minus -3. You end up with 2/3 x to the first power. I'm not writing a 1 there. Well, I can in my work. I'm not in my answer. Y to the -4 minus -3 or plus, and you get -1. We've got to clean this up a little bit. And my fear is that you will leave 2/3 like this. You'll leave x to the first on the top because it's positive, and you'll leave y to the negative 1, or you'll move y to the negative 1 to the bottom because it's negative, and my fear is that you would leave two fractions like that and have a double answer, double fraction. That's not good. And you, of course, would never leave the 1s. So what's in the numerator? 2x. What's in the denominator? 3y. It's going to take just a little thinking, but this is prior knowledge. You know how to work with fractions, numerators, denominators, final answer. All right, a little bit of work to do on your homework for this. Applying all the rules that you already know, plus the zero rule, plus the negative rule. Good luck.